All right, ladies and gents, day 7 here, talking about piecewise functions. Hopefully some of you have seen these before. Piecewise functions basically 3 or 2 or however many different functions actually graphed all in the same graph depending on what our input value is, what our x value is. So if you look up here, example 1 is a function that has 3 pieces, right? There's a blue, a red, and a green. Each one correlates to a different function based on what our x values are. If we have an x value that is less than -4, we use the function x plus 4, and that's what's graphed here in blue. If we have an x value that's between -4 and 1, we're going to use 2x plus 5 as our function, that's graphed here in red. And if x is greater than 1, we're going to use -x plus 3, that's graphed in green. So the big thing here is we notice depending on our x value is depending which function we use and which part of the graph we're going to use. Now if you look at how they're written, we have g of x, or whatever your function may be, f of x, g of x, h of x, equals, a nice little symbol, and then we have it broken down into functions. Normally there's a comma here, I like to write a comma there. And then our restriction on x. What is our x value going to be to use that function? So if you look at the next one, a function of 2 pieces, right? We see 2 different pieces here on our graph. We want to write it based off the criteria given to us. When x is less than or equal to -1, it gives -1/2 x plus 2.5. So that's a function we're going to use if x is less than or equal to -1. When x is more than or greater than -1, it gives 2x plus 1. So if I go here to write my function, my piecewise function, I'm going to write f of x equals, a nice little symbol here, and I'm going to write out both of my functions based off of the criteria, right? When x is less than or equal to -1, so x is less than or equal to -1, I'm going to get the function -1/2 x plus 2.5. Make sure you give yourself enough room, unlike me. X is less than or equal to -1. If x is more than -1 or x is greater than -1, it gives 2x plus 1. So basically what we're doing here is we're looking at our criteria and our function, and we're writing out our piecewise. Yes, the function needs to come first, the criteria second. So now I know if x is less than or equal to -1, I'm going to use this function here. If it's greater than -1, I'm going to use that other function, 2x plus 1. Now, tomorrow, when you see me, we're going to talk a little more about just actually writing these equations based off just the graph. So we're not going to give you any criteria. You have to pull it right off the graph. So just getting down the concept of how we write it is kind of really big right now. So make sure you're doing that. Next thing we're going to talk about is evaluating piecewise functions. So here's another one. It's a 2-piece. Right? We have 2 pieces on our graph. We have 2 pieces in our piecewise. And we want to evaluate h of 0 to start. Well, what we're going to do is we're going to notice x equals 0. So I'm going to figure out what criteria that fits in, because based on my input, based on my x value, it's going to tell me which of these I'm going to use. Well, we're talking about if x is less than or equal to 1, or if x is greater than 1. Well, 0 is less than or equal to 1. So I'm going to use that top part of my piecewise. So I'm going to plug 0 in for x, except there's no x. Because there's no x, anything where x is less than or equal to 1 is going to equal 2. Alright, so our second one, h of 5, so where x equals 5. Well, 5 is greater than 1, so I'm going to use the bottom part of my piecewise. Plug 5 in for x, right, and I get 5, because it's just x. Last one, h of 1, same thing. Figure out, well, I know x equals 1 here. So I got to figure out what criteria does that fit. Is that less than or equal to 1, or is that greater than 1? In this case, it is less than or equal to 1 because it's equal to 1. And my answer is going to be 2 then, because I have nowhere to plug that 1 into. That's it. So basically you're trying to figure out where does our x value fit into our criteria, which does it fit, and we're using the corresponding function with it. Let's try a few more. Graph the piecewise function given f of x equals 2x plus 5 if x is greater than or equal to 5, or -3x minus 1 if x is between -1 and 5, or 4x if x is less than or equal to -1. The biggest part about this problem is figuring out which function we're going to use based on our x value. So if f of 4, I know x is going to equal 4. Well, 4 is between -1 and 5. So I know I'm going to use this middle part here. In that case, I'm using -3x minus 1. Plug 4 in for x. -3 times 4 minus 1. -3 times 4 is -12. Minus 1 is -13. Our second problem. F of -4. So x equals -4. Well, -4 is not greater than or equal to 5. Is not between -1 and 5. It is less than or equal to -1. So I'm going to take -4 and I'm going to plug it into 4x. 4 times -4 gets me -16. Alright, now our last one, f of 5. So we're x equals 5. Is that greater than or equal to 5? Yeah, it's equal to 5, so I'm using my top function. 2x plus 5, so plug that in. 2 times 5 plus 5. 2 times 5 is 10, plus 5 is 15. So the big part when we're evaluating these functions, these piecewise functions, figure out where's our input going, what is our x value, and take the corresponding function that goes with it. Alright, let's talk about drawing them a little bit, because we're going to do that too. So if I'm graphing piecewise functions, right, I have the first part up there. f of x equals 3x plus 2 if x is less than -4, less than or equal to -4, and f of x equals -4 if x is greater than -4. So what I'm going to do is I'm going to pretend this is my function here. So this is number 1, we'll say, this is number 2. So I'll graph the first one first, the second one second. Worry about them one at a time. The first one, I have y equals 3x plus 2. What I'm going to do is I'm going to take my endpoint, in the same color, of -4. And I'm going to let x equal -4. I'm going to plug it in to find my y of x. I'm going to look for 2 points. That's all I need to draw my line is 2 points. One of them is going to be the endpoint. So -4 plugged into there. 3 times -4 plus 2. I get -12 plus 2 is -10. Right? So that's what my y value is. Right? Y equals. So then I know at -4, -10, I'm going to have a point. And that's my first point. I also know, because it's or equal to, it's going to be a closed endpoint. It's going to be a filled in endpoint. So at -4, I'll lose my spot here, -10, I've got a filled in endpoint. I'm going to do it in rect. I'm going to do that part. Okay. Then what I'm going to look at my criteria. It says less than or equal to -4. So what I'm going to do is I'm going to choose one other x value that fits that criteria. Well, if it has to be less than or equal to -4, I'm just going to pick -5 and pick the next one. So I'm going to let x equal -5 then. Plug that into my formula. Y equals 3 times -5 plus 2. Well, y equals -15 plus 2, which is -13. So at -5, -13, I have another point on that part. So -5, -11, 12, somewhere down here. All you need is those 2 points. You can see direction, and then you can draw on your line for that part. Be very careful. Remember that first one you plotted is actually your endpoint, so it shouldn't go past that point at all. So we'll draw our line down. So that's the first part. Right? That was the first section of my piecewise function. Now I need to draw the second piece. So I'm going to do that up top if I have room. So the second piece, I'm going to do the same thing. Right? I have y equals -4. Well, the first point I'm going to plot is my endpoint, which is also at -4. So if I let x equal -4, I try and plug that in. I have nowhere to plug it in. I just get y equals -4. So my first point then, for the second part, is at -4, -4. That is my endpoint, right? We always start with our endpoint. So I look and I see it's not or equal to, so it's an open endpoint. So at negative 4, 1, 2, 3, 4, I have an open endpoint. Then, I'm going to go with the same thing. I'm going to look at my restriction. It has to be greater than negative 4, so I'm going to pick negative 3, the next number greater. Let x equal negative 3. Once again, there's nowhere to plug it in. I just get y equals negative 4. So that tells me my second point is at negative 3, negative 4. So I'm going to go ahead and plot that. Negative 3, negative 4. Put a dot, and now that I know which direction I'm going, all I need are those 2 points. Start at my end point, and I go towards the 1 dot that I had. And I keep going. Right? And that's it. So now I have my piecewise function. I have 1, 2 pieces. So be very careful. You're picking an endpoint first, then you're following criteria for your second point to see direction. Make sure you see whether it's an open or a closed endpoint based on if it's or equal to or not. And then just draw your line in based off your 2 points. Alright, one more example. Example number 2. Once again, we have a 2-part piecewise. First one, negative 2x minus 3, where x is greater than or equal to 3. Second one, x plus 4, where x is less than 3. Take them one at a time. Label them. 1. I'm going to do this one in blue. 2. So, let's deal with the first one. The first one, y equals negative 2x minus 3. The first point I'm going to pick is my endpoint. My endpoint's at 3, so I'm going to let x equal 3. Then, take 3, plug it in to find your y value. Y equals negative 2 times 3 minus 3. Y equals negative 6 minus 3, which is negative 9. So at 3, negative 9, I'm going to have an endpoint. And it's going to be a closed endpoint because it's or equal to. So closed endpoint at 3, negative 9. 3, that's negative 10, negative 9. Okay, then I need to pick one more point for this first one. Well, it's got to fit my criteria. It's got to be greater than or equal to 3. So greater than 3 would be 4. Let x equal 4. Well, take 4, plug it into your original equation to find y. Y equals negative 2 times 4 minus 3. In other words, negative 8 minus 3, which is negative 11. So I know at 4, negative 11, I have my second point. That point's going to show me what direction to draw my line in. So at 4, negative 10, negative 11, I have my second point, and I can officially take my straight edge and draw in my line. Remember, that first point you plot is your end point. You shouldn't go past it. The second one, showing you what direction to draw your line at. Alright, that was just the first part of my piecewise. The second part then. We have y equals x plus 4 if x is less than 3. So part 2, y equals x plus 4. And we said that's because x is less than 3. So I'm going to use 3 again. It's my endpoint, so I'm going to use it. Let x equal 3. Take 3, plug it back in to find your y value. Y equals 3 plus 4, which is 7. So then I know at 3, 7, I have an endpoint for the second part of my piecewise. Well, it's an open endpoint, an open circle, because it's not or equal to. So 3, 7. Oops, I gotta go up a little bit higher. 3, 1, 2, 3, 4, 5, 6, 7. Open circle. And I need to pick one more, a second point to find my direction. I know that x has to be less than 3. Well, less than 3 would be 2. So I'm going to let x equal 2. Let x equal 2. Take 2, plug it in to find your y. Y equals 2 plus 4, which is 6. So, at 2, 6, I have my second point. It's going to show me what direction to draw my line. So 2, 1, 2, 3, 4, 5, 6. My second point. Now that I have my direction, take my straight edge, draw my line through that point. Remember, the first point is your end point. So, 1, 2 pieces. You need to find your end point first, find a point to show direction, and you can draw on your lines. Awesome. We'll do more piecewise stuff tomorrow. Thursday and Friday are review days. We'll have our assessment next Monday. Please, if you have any questions, feel free to Schoology message me, email me. But this is it for the notes today. I will upload these notes slides with the filled-in notes on them to Schoology as well. You can look in the filled-in lessons, or excuse me, the video lessons folder. I'll put this up there. Other than that, subscribe, swipe up.